Hi, everybody. Welcome back to Service-Oriented Architecture. This is the last lecture today. It's lecture 10 on evolution of application landscapes. Here you see it, the last lecture. After, in the first 6 lectures, we talked about the ideal application landscape. And in the following lecture 7 to 9, we talked about the technical side of the game, about integration and technical services and so on. Now in this lecture, we look at the last topic of what we described in the enterprise architecture framework as the last step of our understanding moving through the framework, evolution. So we look at the third dimension, we look at the time dimension now. We look at how to proceed from the as-is situation to a well-defined to-be situation, oriented towards an ideal, towards the ideal that we created. So that's the agenda for today. I'll start with some definitions and some repetitions of what we've learned way back in lecture 1. Then I'll give you a quick method overview of how to plan the evolution, which we then apply using our example of CCT, Christoph Columbus Travel. What does planning the evolution mean there? And some literature at the end. For the definition, let's make a quick repetition of what you've already learned in the first lecture. In the first lecture, when we talked about application landscape and when we stressed the idea that to a certain degree, planning the evolution of an application landscape is like planning the evolution of a city. In this lecture, I already told you that from a very high level point of view, planning this evolution is a 4-step process. And if we have business on the left and IT on the right, what I told you back then and what's a very important takeaway from the overall course is first step is always to understand the business. Since service-oriented architecture is about structuring the business, following the structures of structuring the IT, following the structures of business. So obviously the first step is to understand that business. And inside there we had the business strategy and the business goals. And then we had to define the so-called business architecture in terms of business dimensions, business services and the business service hierarchy and business objects, where business services and business objects being orthogonal to each other. Okay, and then we said, after understanding the business to the appropriate degree, the next step in this abstract view of evolution planning is creating the ideal. We said we do not look at the as-is situation first, but we sort of abstract for that for a while. And step 2 is thinking about how the application landscape would look like in an ideal world. And here the picture of the beacon is characterizing what that ideal is good for. It is the point that gives us the orientation, that tells us where to go to. That is somewhere at the horizon, showing us that there's the land we want to reach. And while talking about the ideal, we spent lots of time in this course. From lecture 2 to lecture 6, I told you how to ideally structure an application landscape in a service-oriented fashion. And we did this very systematically by defining the domains and taking just the information from the business architecture as input. Then mapping, taking the business services and mapping them onto the domains, deciding about the components that implement these business services, and then define how these components are to be coupled, which interfaces are there with which operations, and how to loosely couple. And now, after step 1, understanding the business, and step 2, creating the ideal, now we look at the as-is situation. And the as-is situation is what's really there. When we talked about integration, we said now we talk about the as-is. We talk about the physical world. We talk about real applications on real systems and actual integration necessities. And this is what we look at this step, step 3. We ascertain and appraise the actual situation, and how that is done we'll talk about today. And also we'll talk about how to then, in the last step, create the target architecture that we want to evolve to, that we actually explicitly want to evolve our landscape to, which we call the to-be architecture. So this is, while the ideal is not really to be reached, this is why it's called an ideal, the to-be application landscape is what we actually want to reach via our evolution in, as I always say, 2, 3, or 5 years. So it's a midterm or long-term plan, but it's not the ideal, it's something in between, something really reachable. And this to-be architecture, now, because of our overall process that you see on this slide is also based on understanding the business, and is also based on the ideal. And how that works and how that can be systematically done. This is what this lecture today is about. But before we move there, I want to come back to the idea of the managed evolution. And to understand that, I told you in the first lecture too that what is always there is the need for what we call the fast euro, in quotes. Business, it's their job to create new products, to sell new products, to make the money, and therefore they need IT support. That leads to the case from the IT point of view that there's always a need for operative business support. Business has new ideas about new products or enhanced products or advanced products, and IT must deliver. So there's a force to deliver according to these usually short-term business-oriented goals. And what we say is the ideal is our tool to keep a healthy balance between that fast euro requirement that is always there and our own goal to keep the IT landscape, application landscape in shape, in good shape, to keep it architecturally as sound as needed to be able to manage it. So it is healthy if the landscape evolves in that stress field. This is why we create the ideal for. And that picture, introducing the term of managed evolution, is the main idea of the context behind service-oriented architecture. So you see on the y-axis up there, you see the fast euro, the operative and primarily business-driven development, where starting in our as-is situation, that you see down here, we of course have to improve operative business support through the application landscape. We have to fulfill the requirements of the business. But if we only do this, if we only move in this direction, we very fast we go into that unwanted area where where it becomes more and more hard to do this, to improve the operative business support through IT. And this is when the business side tells us that everything takes so long and it's so expensive, and why is everything so expensive and so on. And to avoid going into the unwanted area, we have the ideal sort of pulling us to the other side that we take care of. So with every step that we take in terms of improving our operative business support, we combine a step into the other direction. We combine a step towards improved alignment of the application landscape to the strategic ideal of business and IT. In a way, this is like refactoring in the large, so to say. And this method allows us to stay in the so-called corridor of balance. So we do not move into the unwanted area here by not only doing steps into that direction, but also doing steps towards the ideal. And that brings us in a managed way, and this is why we call it managed evolution, from the as-is state that we have today to a well-defined to-be state that we strive for via our projects of the next 2, 3, or let's say 5 years. And that is the definition of managed evolution. Grabbing these ideas together, here it says managed evolution is a method for developing an application landscape which balances operative and strategic requirements. The operative requirements are short-term and usually business-driven, and the strategic requirements are expressed by the ideal of the application landscape. Okay, so now the question is, how can we plan this evolution? We have to plan this scope of 2, 3, or 5 years. As we always do in Quasar Enterprise, here also we have an abstraction in terms of a 5-step method. This is the systematic way of evolution planning as we see it. So 5 steps. First step, now we have to analyze the application landscape as is. The overall process, this is step 3. Since we are only talking about step 3 and moving to step 4, from the as is to the to be, the actual evolution. So the first step here is analyze the application landscape as is. Having done that, we need to identify the activities that are needed, the actions to be taken within our application landscape. And from this set of all necessary activities that may be there to bring us closer to the ideal, we now have to choose, and we do this systematically by first determining some main scenarios in step 3. That means a scenario covers some of these activities needed, and we may have some of them, many reasonable scenarios, which we then systematically score against each other to end up in step 4 with the actual design of the application landscape to be, which results as the selected set of activities needed. And after doing that qualitatively, we also have to look at the efforts and map that onto the timeline. And so step 5 is determining the roadmap. In a way, this is a little abstract. You see it on the picture here. Analyze the application landscape as is leads us to a model of the as is situation. Identify the activities needed leads us to a set of activities referencing local changes to the as is architecture, determining main scenarios. Now grab some of these together and define different ways of how to move into the corridor of balance. Selecting from this scenario then leads to the actually to be planned to be application landscape, and determining the roadmap takes the efforts of all these steps and defines so-called steps and stages and puts everything on the time scale. And to get a good understanding of that, we now use the method in the context of our example of CCT. You remember in our running example, the travel company Christoph Columbus Travel. The origin of everything that happens was this one new business requirement. The business requirement is that in addition to the classic package holidays, now the company also wants to sell so-called custom holidays. The custom holidays shall be offered. While packaged holidays are pre-packaged in advance by product management of the company, they found out that many customers would like to have more individuality, would like to individually configure their custom holidays. Okay, now we want to offer that. What needs to be done? So after we understood the business and created the ideal, in analyzing the as-is situation now, there may be many views and many aspects to take into account. And what you see here is at least 3 layers of information are of interest while analyzing the application landscape. The middle layer here is what we call the core area. This is where the physical information system component information lies that we have to analyze. And then we also have a layer below that, which we call platform strategy. You'll see in a second what's in there. And the third layer on top, which contains information about the relation to the ideal. But let's start in the middle, the core area, IS physical. What are we interested here? The main thing, of course, is the physical AL component that we have to analyze, we have to understand. So we will come up with a list of physical AL components. And these AL components are organizationally linked to a business unit, usually. So a organizational unit that takes responsibility for the physical AL component. That's another kind of information we'd like to analyze. And then what are the physical interfaces that are imported, that are exported? What types of interfaces what types are these interfaces of? And then concerning the physical coupling, how is it implemented? How is access to the physical interfaces organized? That's the core area in a way that we want to analyze. And now on the lower level, this is where platform strategy comes in. Now we want to know more. We do not only want to know about the physical AR components, for example, we also want to know about which application platform these components run on and which organizational unit is responsible for that. And maybe on which logical hardware platform the application platform runs, and maybe on what physical hardware platform the logical hardware platform runs. And on the other side, concerning the physical coupling, which integration platform is used and which technical services of integration are used. So we not only have to analyze the logical structure or the physical structure in terms of AR components, but we also have to analyze the as-is integration architecture. That's one area of many other aspects to take into account. And the third area up here, the relation to the ideal, is what we need to understand before we can match to the ideal and find out where the what the activities needed are. So what is the category? Is there one or many categories the physical component actually belongs to? Which domain does it provide services for? Which logical AR component does it therefore implement? which logical interfaces does this AL component import or export, and which business objects are managed by the physical AL component. So lots of mappings between the physical layer and the ideal. In some abstract view is that analyzing the application landscape as is logically is a four-step process. So of course we start by specifying of the relevant AL components. That means when ascertaining an actual application landscape, only AL components specified IT controlling and existing for the relevant service level agreements with the company are considered. That's important because usually in real enterprises, there are hundreds or thousands of second level quick and dirty mini applications or systems around, like Excel sheets or Access databases in special departments or whatever. So we have to define the scope of what we actually have to look at, and usually it is components specified in IT controlling with relevant service level agreements. If we have that scope, then we need to determine the relevant ascertainment criteria. On the slide before, I showed you the collection of many possible ones, but to define the scope for what we will actually do is that we need to choose from these criteria. The ascertainment criteria are context dependent, and the assignment to domains in context agility, for example, is of particular interest. Then, first step, we have to define the characteristics. This is where we then really need to go and look at existing documentation and talk to people, knowing these applications. So usually we have structured interviews, and to give you a rule of thumb, if you write down all the information about one component, usually it should not be more than 5 A4 pages or whatever. Otherwise, you probably go into too much detail for one component. And and the last step, of course, is then filling in these characteristics. For the execution and post-processing of interviews, approximately 1 day is required for every AL component. So what you see is if you have hundreds of components, you will need hundreds of days to just do step one, to just do the analysis, even though in sub-steps 1 and 2, we already tailor the scope to be handleable. There's some best practices actually around for the analysis, for creating these documentations. One is to get used to it. So it's a good idea to start small. So in the first step, only outlines of the characteristics for some AL components and their interfaces are required. So it's an adaptable process in a way. The most important should go first. So the second step should be limited to the most important AL components. That's usually 2/3 or 3/4 of the ascertainment scope. The finalization is then the last step. The third step should be the ascertainment of information still outstanding. Using graphics is a good idea, and ensuring the serviceability, meaning the ascertainment criteria should, in regard to scope, represent representation, form, and maintainability. They should be designed such that project leaders and those responsible for components can service and use them without any great overhead. Experience has shown that this serviceability is only possible with the aid of tools. So before we do all that, select the appropriate tools that apply where these best practices can be mapped and that can be used for all the selected criteria of our analysis scope. Okay, so that's step one. Step two now is to identify the activities needed. Now we've got a complete understanding of our as-is situation, physical AL components, the underlying technologies, the application and integration platforms and their usage, as well as the mapping of what we found in the as-is situation towards the ideal situation. And from that, now we can find out what the necessary changes are. And we can do this systematically again. And this is described on that slide. The slide says that there's operative requirements and strategic requirements. We take the application landscape as is, look at the operative requirements hierarchy and find out what there is to do. That's one part of the set of activities needed. And for the strategic, meaning concerning the ideal, we not only take the information from the as-is, but also from the ideal and from the platform strategy, if there is one. And all that goes as input into assessing the strategic requirements. And out of there comes evaluation criteria and activity candidates. And this is again a systematic SWOT analysis-based process, because there's so many of them that not using a methodology, you will never be able to actually perform this strategic requirements assessment. So at the end, we get a second set of activities needed. So we have activities needed resulting from the operative business-driven requirements on the one hand side, and from the strategic IT-oriented requirements on the other. If you write that down, the results set down, that really much looks like portfolio, like we know it from classic project portfolio management. So here's a typical example of that. So what you see is you have 3 projects, A, B, and C, and these projects help us taking care of the needed activities. Each project targets one or more of these needed activities, and then we have to for being able to now define scenarios and prioritize, we have to grab together all the needed information for these projects, like efforts and costs and so on. Okay. So it says identify AL components for which project requirements accumulate and prioritize strategically driven actions in particular. This is what we have to do here. Concerning the strategic requirements, we now come to find differences from the ideal, and only a little surprising, the categories or the aspects of these differences together capture all the ideas that went into defining an ideal structure. So that may be an issue of domain purity. Can the physical AL component be assigned uniquely to one domain, or do we have to act? Functional structuring, can the AL component be assigned unique functional criteria, or do we have to act? Category purity, can the physical AL component be assigned unique functional category? Is there one concern regarding our 4 categories? You remember data, function, process, and interaction. Is there a An easy mapping to make: is there one and only one prime goal, or are there many? And if there are many, we have to act. Dependencies in accordance with categories. Do functions components should do, for example, function components not call process components, and so on? So do we apply to the communication rules of our reference architecture, and so on and so on? You see, no cyclic dependencies, tight cohesion, data sovereignty, appropriate degree of coupling, functional redundancy. All these aspects that we defined of how they should look like in an ideal may lead us to defects and necessary activities to be taken, activities needed from a strategic, IT-driven point of view. One of these aspects was the aspect of how the as-is application landscape matches our ideal domain structure already. So what you see down there on the left is the ideal domains from CCT, and up there on the left is the as-is situation. So we now contrast the as-is situation with the ideal domain structure. And what we find, you see that on the right, is that in the as-is situation, there are components that belong to one and only one domain. So there is, from that point of view, there's no activity needed. But there are activities needed where we either have more than one domain, and you see that here, for example, there are 2 domains, or here there are even 3 domains. This is a typical monolith in the middle of everything that's already there, typical monolithic, big central application block that covers functionality or responsibilities of many domains. And to come closer to the ideal, we obviously have to cut things a little smaller. Maybe over time migrate to a situation where we do not have that one big monolith, but at least 3 components that then belong to one domain only. This is one situation you can find, and the other situation is what you see down here. There are components that you find out about in your analysis, which are not AL components, but actually part, in a well-organized world, part of the integration platform. Yeah, technical services implementations. These are the typical 2 situations: multiple domains allocated to logic to IS components, or technical components which should actually belong or be regarded as belonging to the integration platform. So this is there we see the activities needed. We may need to restructure here. We may need to restructure there. We definitely need to restructure here. And maybe we need to take into account whether this is set up correctly. Doing this for the complete scope now yields a large set of activities needed. And with regard to the ideal application landscape, in terms of the components structure, there are multiple types or multiple categories of these activities. So with respect to the ideal component structure, as-is components may need to be actualized. They may need to be migrated from one platform to another. They may need to be extended. Maybe they're not there already. So in the ideal world, we have a component defined where there's no implementation for in our actual as-is situation right now. So it has to be newly built. Maybe there's some renovation that has to be taken into account, or we decide about buying some standard software and customize that and integrate it into the application landscape. So different categories of activities needed it's always worth to qualify the activities needed as a good basis for the next step 3. Step 3 now is determining scenarios. And working with scenarios comes into the play because the large number of activities needed that you usually get from the analysis phase, step 1 and 2, this is so much and so complex that you cannot decide about which of these activities to plan for, which of these activities to put into your roadmap, and which to leave out systematically in one step. So this is where scenarios come in. A scenario grabs together one defined set of activities. And the idea of systematically doing scenario analysis is to define so-called main scenarios. Main scenarios in the details and the actual number of, so to say, lower level activities, they may differ, but they describe the main idea behind this more or less already defined set of activities. And here in this example, there are 2 typical scenarios of modernization of our application landscape from our CCT example. So there's one scenario that's called new business first. So defining a scenario not only means to put together a set of activities, of main activities, but usually we also give them a name, and the name here is new business first. What does it mean? So the in the example, offering the custom tours and the advanced CRM that goes with it, the customer relationship management, these operative issues are both very important for us. So since we want to have both, we determine components involved plus the activities needed with these 2 activities bundles. And concerning our large-scale refactoring, concerning our optimization of our architecture, coming closer to the ideal, we map some steps, like for example, to migrate the resource management system, build the tool configurator, and customize the customer management. 3 of these strategic issues we apply as a balance. And this brings us to the idea that determining one scenario is a 3-step process. So we first select primary drivers. In the scenario new business first, the primary drivers are we want to have a clear focus on the business requirements. So we have offer tours and advanced CRM. These are our primary drivers. That determines the scope, and from within that scope, we apply some balance for evolution in the other dimension. Okay. And the same is true for the alternative scenario on the right, which is here called replace the host first. So in this alternative scenario, we find out that we have a big and important issue on the IT side. So we want to get rid of a platform, and this is very typical today. Let's say, for example, replace the host platform that we have, or at least one of the many host platforms that we still have in our application landscape. And that leads us to the strategic issues: migrate resource management system, build tool configurator, and migrate product management. These issues are all to be fulfilled, or all to be taken care of before we are really in the position to replace the host. And if this is our main driver, That leads to a special scope, and this scope is a little different from the new business first approach. So within this context and within the time box or the effort box or whatever, within the limits of the program we are now setting up for our next 2, 3, or 5 years, in addition to these primary drivers, we can only apply as balance from the business side, offering custom tools, for example. So advanced CRM will not be able to be also done like it is in the first scenario. So these two scenarios, in a way, have are different ways, but both stay in the corridor of balance. The first one stays in the corridor, but moves a little more towards the fast euro, and the second stays in the corridor, but moves a little more towards the ideal. These are two main scenarios, and in the real world, usually you have more than that. And it is worth all the effort to think about defining these main scenarios, because then you can take them as a basis for systematically scoring. So we take the two scenarios. We set up a scoring mechanism, define priorities, define weights, and then define the fulfillment of these single characteristics of the scenarios. That leads us to a preferred scenario, which internally may then, looking at the lower level activities needed, may lead to a set of possible to be application landscapes, and from these, in a second step, lower level secondary scoring mechanism, we select the to be application landscape that we actually strive for. Okay, while step 1 and 2, the analysis of the as-is application landscape, probably easier to understand why this is necessary. Step 3 and 4 looks a little complicated, but it is a lesson learned from reality that it is very fast you get into the situation that it is way too complex to come up with a solution with all the many possible activities needed for a reasonable modernization of your application landscape, so that you will not be able to cope with that complexity if you don't have a systematic process. So now, using that systematic process via main scenarios and scenario analysis and scoring methods, we end up with a to-be application landscape. That's how the application landscape really should look like, containing all the necessary actions to be taken. And now we, in the last step, have to determine the roadmap. So we need to determine the efforts of all the single steps. And then we need to break that down into so-called steps and stages. A step is one or more carrying out one or more of these activities or parts of these activities, a set of whole or parts of activities. And the stage is defined by taking something into operation. So when we want to determine the roadmap, we not only have to talk about the steps, we also have to think about the stages. And what you see on that slide is that the one extreme in terms of stages is the so-called Big Bang. In the Big Bang scenario, there's only one stage. So you put together everything and you put it into operation completely. This is what you see on the left-hand side. Only one stage. This is the Big Bang. The implementation costs, you see this as one curve, are the lowest for that scenario because staging takes effort. We need to look for technical bridges, technical intermediary solutions, and so on. So if we only have one stage from the expected implementation costs, it is the lowest. But the risk costs are the highest. And risk costs meaning costs that come up if risks really end up being problems. Okay. And then as a third curve, you can add together the benefits, saying when is the benefit to be taken? And if everything is taken into operation in only one step, the benefits come quite late, in contrast to more steps where step-by-step benefit is added. Okay. Having more steps leads to a decrease in expected risk cost, but obviously an increase in expected implementation cost and an increase in benefit. So if you add together, if you sum up these three curves, what you'll find is a so-called cost-benefit ratio, and it looks something like the curve on the right-hand side. So while the Big Bang on the left has a quite low expected value, overall value, and too many stages on the right, like 5, 6, or even more stages, also have a lower value. Somewhere in between is the optimal number of stages. Here in this example is with 4 stages. So we should plan after we did the analysis that you see on that slide. What we should do is we should plan for 4 stages, because there the sum of expected benefit, risk costs, and implementation costs has the optimum. Determining the roadmap not only means determining the stages, so the parts of the overall implementation that is taken into operation. It also needs to define the steps. And for the steps, it is interesting to know that one step internally may be decomposed into a number of typical sub-steps. And this is what we very often call a reference scenario. And here's a reference scenario for building up a new business data component as a centralization measure, for example. And while setting up the new business data component as a centralization measure is the overall activity needed, the reference scenario now says that there may be sub-steps. First sub-step is what you see here. We have a component A that implements a data service and that yields a data type interface, and we have a component C that uses that data services via the data type interface, so sort of directly interacts with the data from A. Typical first step now would be to implement a business data component to later on take over the responsibility. Concerning A and C, nothing has changed, but now there is a new component B that has one clear category, being data, and now we can work with that. Step 2 would be some sort of interim integration, maybe. So the new component now gets coupled with the old components, and the old component A will get changed. So data management, for example, will be disabled, but data propagation is still there, and the new component B now yields an interface that it used from C. Okay, so we have, as the step is called, an interim integration, which can then be further optimized towards a modified integration architecture, where the data propagation from B to A still happens via the D-type interface, but the new component that we that we are striving for, the new component business data component B in the middle, now yields a logic type level interface to be used from C. And then in the last step, we can reverse the relationship between A and B by no longer B propagating data, but A calling the same service that C calls. And maybe that is the final step, or the final situation that we want to achieve with our activity needed of our selected scenario. But maybe in our roadmap planning, we don't have money to do everything. So maybe it's good enough to only proceed up to sub-step 2 or maybe sub-step 3. And maybe we do step 4 later. Okay, and this is where these reference scenarios of modernization are good for. And all of this analysis, whether it's about the stages and the Big Bang versus multiple stages on the one hand side, and how to further decompose the implementation of an activity needed into sub-steps according to reference scenarios, putting all that together then leads us to the so-called roadmap of all the steps and stages. And here you see an example from CCT. What you see is we have 6 steps and 3 stages. Okay, so we start with a step 0, which is a pure infrastructure step. We just make sure that we have the needed technical infrastructure, application, and integration platforms to work. And then in step 1, we do the customization of the customer management system and do some adaptations of old systems 1 and 2. And this defines stage 1. So we have one part of our overall roadmap to be put into operation. Now we have a productive infrastructure plus the advanced CRM. See, this is for the main scenario, new business first. And then we have a second step to build the new virtual resource management and build the individual booking system and extend the portal. And then from step 5, building the tool configurator, we sort of do only part of that, only a subset of steps. And so a reference scenario in this case may, for example, be to do this for only pirate areas. So a decomposition of the data needed. So this then defines stage 2. This goes into production. So we not only have the advanced CRM, now we also have the new product model for custom tours, but we only have that for pilot areas. And then we can learn from that. We can minimize our risk costs. And stage 3 now takes all the rest, takes all the areas. And in this example, the optimum is with 3 stages and these steps that you see here. That's it for today, and that's it for the course. The literature is, of course, again, the book on Quasar Enterprise, Anwendungslandschaften serviceorientiert gestalten. And the lecture on evolution is the chapter on evolution is chapter 8. And there you can find all the much more background information on what I just told you in that last hour. So thanks very much for listening. Thanks very much for taking the course. Good luck in taking the examination, and see you next time around. Thanks very much.